Today we're going to be talking about two other ways to prove triangles congruent. And these are technically all theorems. So it's something that we can prove. We're going to prove the first one. I choose not to prove the second one. So if angle B is congruent to angle E, and angle C is congruent to angle F, and AC is equal to DF, we need to prove these triangles are congruent. Now here, notice what we're given. We're given angle, angle, and side. So we're proving the angle, angle, side way of proving triangles congruent. Okay, first we start with our given. Angle B is congruent to angle E. Angle C is congruent to angle F. And then AC is congruent to DF. And this is what we are given. Step 2. Okay, now we can only use the ways that we already know for right now. I know that if I have two angles in a triangle, congruent to two angles in another triangle, the third angles are congruent. So I know angle A is going to be congruent to angle D, because if two angles in one triangle are congruent to two angles in another triangle, then the third angles are going to be congruent. Okay, so now what I've said is I've said angle A is congruent to angle D. So therefore we now know these triangles are congruent. Triangle ABC is congruent to triangle DEF because of our angle, side, angle postulate. Okay, so again, those were postulates that we've been using before. But now we have proven that if I'm given two angles and the non-included side, remember, angle, side, angle was the side that was included between the two angles, versus angle, angle, and the side isn't between. The side is going to be opposite one of the angles we're given. Okay, the other way is hypotenuse-leg. So in a right triangle, the hypotenuse is the longest side, and it's the side that is opposite of the right angle. The other two sides are called legs. They are not necessarily congruent. But if in a right triangle, so down below here, if I have a right triangle, and I have one leg congruent to another leg, and the hypotenuse congruent, and this is only in a right triangle, then our triangles are congruent by hypotenuse-leg. So, summary of ways to prove two triangles congruent. Any old triangle you want. There is 4 ways. Remember these first 4, the first 3, those were postulates. That was a theorem that we just proved at the beginning. And then right triangles, HL, this is also a theorem. I just choose not to prove it. Okay, so we're going to do some proofs. Our first one, DL bisects BN and X LN is congruent to angle XDB. So XLN, this angle here, is equal to XDB, that angle there. I'm trying to prove that LN is equal to BD. Okay, our first reason is always that we are given. Now, two things I want you to think about. First, with your proofs, always think about where you're going. I'm trying to get LN congruent to BD. So I'm trying to get those segments equal. What triangles, if you mark up your diagram, you could start seeing, okay, I have an angle. I have these vertical angles equal, so I'm going to mark up those vertical angles. So let me state that next in my proof. Angle BXD is congruent to angle LXN because vertical angles are congruent. Now, if I could get another side congruent, let's look at this first part of this given. DL bisects BN. So DL, this segment DL, is going to bisect BN. So from that statement, from that piece right there, I can say, since DL bisects BN, that DL, that X is the midpoint of BN, because that is the segment that is being bisected. And that's by definition of a segment bisector. Next. So if X is the midpoint of BN, I know this segment is congruent to that segment. So therefore, I know BX is congruent to XN by definition of a midpoint. So let's look at what I have here. We have this bottom triangle, which has the side in it you're trying to prove. We have the top triangle, which has the side in it you're trying to prove congruent. So what do I have? Well, I have angle, angle, and the non-included side. So that is using our triangle LXN is congruent to, now be careful, DXB. LXN is congruent to triangle DXB by angle, angle, side. That's our new postulate. That's our new ways. Or I'm sorry, our new theorem. So now that I know those are equal, I can say that the corresponding parts, which are LN and DB, are congruent by CPCTC. Okay. Now this next one. I know KM is perpendicular to JL. JN is perpendicular to LK. And that KM is equal to JN. What am I trying to prove? I'm trying to prove JL, big side there is equal to LK. Now here comes the hard part. Think of everything that you know. Where have you tried to say that two sides in one triangle were equal? Well, I knew that if I knew the base angles were equal. So if I could get these base angles equal, then I could get the larger triangles equal. Let me pull out some triangles for you guys. We have what we call overlapping triangles here. Redrawing. I have triangle KMJ. With a right angle. And similarly, I have another one. That is JNK. And in these triangles, we knew that JN was equal to MK. Well, look at these triangles. These are right triangles. They share the common side of JK. With sharing of that common side, we now have these triangles congruent. With those triangles congruent, I know that angle K is going to be equal to angle J, which is what we needed. Whew! Now I just got to put this in a proof. Okay, first, KM is perpendicular to JL. And JN is perpendicular to LK. And we also know that KM is congruent to JN. Okay, we are given this. Step 2. Alright, we know that perpendicular lines, so take this piece we're given, our perpendicular lines form right angle. So angle JMK and angle JNK are right angles. That is because the definition of perpendicular lines. So then I know triangle JMK and triangle JNK are right triangles. I need to state that if I want to use hypotenuse-leg, because that's definition of a right triangle. I need to state that they're right triangles so that I know that that's the reason I'm using. Alright, hypotenuse-leg. We've said JK. We've said that the legs are equal from the given. KM was equal to NJ. I need to state the hypotenuse is JK congruent to JK by reflexive property, then, now that I have that, I know that triangle JMK is congruent to triangle, alright, I gotta make sure I do this correctly. I started with J. J is equal to K, so K, my right angle's in the middle, so NJ by hypotenuse-leg. Hey, so now we have congruency by hypotenuse-leg. I know that angle, and I have to list this by 3 letters, L, J, K. Because if you look at the big picture, there's a lot of angles in there. LJK is congruent to angle LKJ by CPCTC. Then, since I have base angles equal, to get these sides equal, JL congruent to KL. Okay, when I go angles to sides, that's converse of the isosceles triangle theorem. Okay, so key things in that proof. I pulled out the overlapping triangles. That was really helpful to me. I marked up my diagram. I thought about where I was going before I started on my proof. Okay, there are your lesson questions. Which congruent methods can be used to prove the triangle is congruent? So please make sure that form is submitted on time.